Hi there, this is mg5004 and the corresponding DE paper. This is part 2 of topic 1, and we're going to be looking at not chapters 1 to 4 but chapters 3 to 4. Sometimes we need to abbreviate numbers. They might be just too long, or we're not required to use that amount of accuracy. Let's look at decimal places first, because there's two ways of doing it. We can use decimal places or we can use significant figures. In this particular example, we're going to use decimal places, and the first one asks us to write to 4 dp. So what we need to do is we need to look at 6.38623. And if we've been asked to write it to 4 dp, we actually have to look at the first 5 digits after the decimal point. So 1, 2, 3, 4, 5. And we need to have a look at the 5th one. And the 5th one is only 3, so it's less than halfway. So that means we can round down. So we can say that 6.38623 is 6.3862 to 4 dp. If we need to write it to 3 dp, then we're going to look at the 4th figure, the 4th digit, and if we look at that, 1, 2, 3, 4, it too is less than 5, so we can round down or we can ignore the last digit. So to 3 dp, we'd approximate it to 6.386. Part C, to 2 dp. This time we need to look at the 3rd digit. So we're going to look at the 1, 2, 3 digit. Now this time it's over halfway, so we're going to round up. We're going to round the previous digit up, so we'd write that as 6.39. And for the 4th part, we're asked to go to 1 dp. So let's look at that, 6.38623. So going to 1 dp, so let's look at the 1st and the 2nd digit. The 2nd digit is greater than halfway, it's 8, it's more than 5, so that means we round up the previous one, so our answer would be 6.4. This is just a way of approximating. Similarly, we can use significant figures to approximate a number. Let's have a look at the first one. The first one says 5 significant figures, so we have 86.97529. So we'll look at the 6 digits, 1, 2, 3, 4, 5, 6. And if we look at that, the 2 is less than halfway, so we're going to round down. So our answer would be 86.975. Part B asks us to go to 4 significant figures. So again, we'll look at 86.97529. So we need to look at the 5th digit, 1, 2, 3, 4, 5. So that's a 5, so we're going to round up. So this time to 4 significant figures, it would be 86.9. So we round up the previous one, 8. To 3 significant figures. Let's write it out again. Right, to 3, so we're going to count 3, 1, 2, 3. We're going to look at the 4th one. The 4th one is over halfway, so we're going to round the previous one up, but we can't round that up, so we actually have to round it to 87.0. D, we're going to round it to 2 significant figures, so we need to look at the first 3, 1, 2, 3, and we need to round that up, which we can't, so we're just going to write it as 87. So that's the number approximated to two significant figures. To one significant figure, we're just going to look at the first two digits, and we note that the second one is greater than halfway, so that means we're going to round up the previous one, and so it would be 90. Yes, there are two digits in the answer, but there's only one that's non-zero. Percentages are just another way of looking at fractions, and percent means a fraction out of 100. So it's always going to have 100 as the denominator. Let's have a look at question A. What percentage of a 3-hour exam remains once 35 minutes have elapsed? Well, 3 hours is 180 minutes. And if we take off 35, that's going to leave us with 145 minutes. Okay, now we have to look at 145 as a fraction of 180, and we can write that as 80.555, depending on the level of accuracy, percent. Question B says a car auction, the auctioneers are paid 4% commission, and if they receive 250, what did the vehicle sell for? So what we know is that 4% of X is equal to $250. We can write 4% as 0.04x, and that still equals 250. So from there we can just solve for x and say that x is 250 over 0.04. Use your calculator. $6,250 is the cost of the vehicle. The percentage change formula is a really useful one to know if you're looking at something that's changed in price, changed in length, changed in temperature, and so on. Suppose you have something that original price was $135 and it's now $149.99. So that's the new value. What's the price gone up by? So we'd look at the percentage change by looking at the actual change. So the new value is 149.99. We'd subtract the original price and we'd divide by the original price, and we'd multiply then by 100. So using your calculator, 149.99 minus 135 divided by 135 is 11%, roughly. We talk about a rate when we want to compare two quantities, and the quantities are measured in different units. And usually, or often, we use the word per when we're talking about a rate. For example here, kilograms in days. So let's look at the question. It says find the rate at which the goat is eating. So, okay, let's compare them. We've got 110 kilograms in 50 days. So that means if we do the arithmetic, it's 2.2 kilograms per day. So it's a rate. It's kilograms per day. A ratio, though, measures or compares quantity that are measured in the same units. So if we have a look at the example there, a craftsman is building a model of a sailing boat using a scale of 2 to 75. The height on the mast on the model is 20 centimetres. So what is it in actual fact? So we've got a ratio of 2 to 75. So that's the same as 20 to 750. Now this is all in centimetres, so therefore the height is either 750 centimetres or 7.5 metres. Okay, the speedo is calibrated to read faster than the actual speed, and a speed of 55 kilometres an hour shows us actually 60 kilometres per hour. So find the actual speed when the speedo is showing 90. So let's have a look. We've got 55 is equivalent to 60. And what we're looking for is to find what is equivalent to 90. Okay, that 55 is a proportion of 60, so we could go 55 out of 60 times 90. And that would give us that the actual speed would be 82.5 kilometres per hour. Just check that on your calculator. What speed shows when the car is travelling at 120? Okay, let's use the same proportions. This time it's going to be sort of the other way around. We actually want our speed to be larger than 120. So x is going to be larger than 120. So we could look at the fractions. X over 120 is equal to 60 over 55. In the first part, we knew it was going to be smaller, but in the second part it's going to be bigger, so that it's going to be upside down. So just using basic fraction knowledge, 55 times x is equal to 60 times 100. X is equal, 120. X is equal to 60 times 120 over 55. And you'd need to use a calculator to do that. And the final answer would be 131 kilometres per hour. Often these sort of questions are easy to do with a diagram. I won't draw the whole diagram. I'll just draw part of the diagram so that this length is 3x, this length is 4x, and this length is 6x. Now we know that the volume is 9,000 centimetres cubed, so that should tell us that 3x times 4x times 6x is equal to 9,000. So 3 times 4 times 6, so 72. X cubed equals 9,000. And we're just going to use basic algebra to say that x cubed is 125. So x must be 5. So therefore the sides must be 5 times 3, which is 15, and 4 times 5, which would be 20, and 5 times 6, which would be 30. The second question, 2 of the huskies had died. There were 8, now there are only 6. So now we've only got 6 out of 8 huskies, or 3 out of 4 huskies. So we only now need to have to feed 3/4 of the dogs. So the food will last longer. The food will now last 4/3 as long. So we need to divide, well, probably one way of doing it is to divide 12 by 3/4. And then that's 12 times the 4/3. We could have, either way, we could have come to the same answer. We could have multiplied it by 12 or divided it by 3/4. So then the food will now last for 16 days.